This is Mr. Peter, and in today's mathematics class, we'll be talking the topic of binary operations. Binary operations from the word binary, that's two. These are operations that combine two elements of a set to produce another element of the same set. Binary operations are operations that combine two elements of a set to produce another element of the same set. Addition and multiplication are common examples, okay? Before we jump into the general properties, let's talk about numbers. All right, let's talk about types of numbers, the set of numbers. We need to understand the set of numbers so that we know how to define our binary operations. Okay, we'll start with the first set of numbers or type of numbers, n, stands for natural numbers. So when we have the symbol capital letter, it stands for natural numbers. Natural numbers are integers greater than 0. Our normal counting numbers from primary school, 1, 2, 3, on to 1 million, 1 billion. So those are your natural numbers symbolized by capital letter N. Then we have a set of integers Z. Okay, so it's positive or negative integers. It could range from minus 1 million to minus 100, 0 plus 1 plus 5. So Z is for the set of positive or negative integers. Q, the set of rational numbers, positive or negative fractions, including exact decimals like 3 over 5. This is going to give you exactly 0.6 or minus. We also have minus 5 over minus 3 over 5. Okay, then we also have recurring decimals still under a set of rational numbers. For instance, 10 over 3 gives you 3.333 till infinity. So it's a recurring decimal. The 0.3 keeps recurring. All right. Okay. Lastly, we'll talk about irrational numbers. Irrational numbers are, as the word says, irrational. Okay. Example, pi. Pi is 3.141, and the numbers keep getting different on to infinity. So it's a non-recurring decimal. It's not like 3.33 that's recurring. Okay, so it's non-recurring decimals. We also have surds. Surds are rational numbers like root 2. Of course, if you point that in your calculator, you see the numbers after the decimal point keep changing on forever. Okay, so it's non-recurring. Not that the numbers after decimal point are not the same. They keep differing. They are different. Same thing with 5. So surds are irrational numbers. So we've talked about natural numbers greater than normal counting numbers. Then integers, which are both negative and positive integers, as said. And we have talked about rational numbers, which are basically negative or positive fractions, like exact decimals like this 0.6, or this one that is recurring decimal. And finally, we talk about irrational numbers. So we can put all of them into a set of real numbers. So R is a superset of real numbers. So it covers your natural numbers, your integers, your rational numbers, and your. We're back to the binary operations. So these are operations that combine two elements of a set to produce another element of the same set. For instance, addition and multiplication are common examples of binary operations. 3 plus 5. You are combining 3 and 5 to give you 8. 3, 5, 8 are members of the same set. So you are combining two elements, 3 and 5, to give you a third element, 8. Or 3 times 5 gives you another element, 15, which belongs to the same set as 3 and 5. So those are binary operations, addition and multiplication, common examples. Subtraction and division are also common examples of binary operations. Now let's look at the general properties of binary operations. One of the first properties to look at, or characteristic if you like, is closure. The property of closure. What do I mean by closure? For all elements A, B in the set, the result of the operation A, operation B, this is a common symbol for binary operations, this asterisk. So A, operation B is also in the set. Okay. So for all elements A, B in the set, the result of the operation A, operation B is also in the set. So that won't be closed. For example, the set of natural numbers, okay, is closed under addition. Okay, for example, we're talking about the property of closure. Okay, for example, the set N, that's a set of positive natural numbers, your counting numbers, is closed under addition and multiplication operations. However, the set N is not closed under the subtraction operation. What do we mean? Look at the operation of addition. 2 plus 5 7. They all belong to the set of natural, your positive counting numbers, right? Look at the operation of multiplication. 2 times 5 gives you 10. Sorry, 2 times 5 gives you 10. Correct that. So you can agree that 2, 5, and 10 are all positive natural numbers. But look at subtraction. 2 minus 5 it gives you minus 3. 2 and 5 belong to the set of your positive counting numbers, but minus 3 is not a positive counting number. So the set, that's what I mean like that. Subtraction is not closed, okay, for that set. So we say the set n is not closed under this operation, okay. So that's the property of closure. So this set is not closed under the subtraction operation because minus 3 is not, it doesn't belong to the same set as its two operands, 2 and 5, okay. Jump into another property of binary operations, the commutative property. So the commutative property is basically mean that for all elements A and B in a set, the operation A operation B is equal to B operation A. Okay, so if you swap positions, if the two operands swap position, it should still be equal. For example, the operations of addition and multiplication are commutative for the set of real numbers. No, R is a set of real numbers. That's a large set. As for instance, A plus B should give you B plus A, and A times B should be equal to B times A. So if you swap positions, the answers remain the same. However, the operations of subtraction and division are not commutative. So we're talking about the commutative property. What do I mean by commutativity? Okay, so these operations of subtraction and division are not commutative for the set of real numbers, as A minus B is not equal to B minus A, and A over B is not equal to B over A, unless A equals to B, okay? So this subtraction and division are not commutative. For example, you can test with 3 and 7. 3 minus 7 is not equal to 7 minus 3, and 3 over 7 is not equal to 7 over 3.